Hi everyone, this is Akim Yagantishwadu. Welcome back to our machine learning session. In this session, I'm going to discuss how to practically implement decision tree on top of our diabetes dataset. For theoretical concepts about how the decision tree will work, that already discussed in separate sessions, go and watch on top of theoretical concepts of decision tree, how to construct a decision tree. In this session, I'm going to show you practical implementation of decision tree. Let us open our Jupyter notebook. So already these topics already I discussed in the previous sessions and how to read your diabetes data set, how to construct a data frame. So we are going to use pandas a data frame to construct to read your CSV file and which will construct a data frame. And top of our data frame already explained how to divide the data into train test split. Before dividing train test split, what you need to separate? You need to separate all the inputs into X variable, all the outputs into Y variable, and then divide your data set into train and test split. To train your model, train set is required. To test your model, test set is required. If you missed any sessions, go and watch our previous sessions. Directly, we will jump into our decision tree implementation. In order to do decision tree implementation, first you need to import the package related to decision tree. Decision tree. So from sklearn sklearn.tree import decision tree classifier, decision tree classifier. You need to remember these names, small letter, capital letter. Python is completely case sensitive, right? So D is capital, T is capital, C is capital, decision tree classifier. Execute this cell, and this we are going to use this package to create your decision tree object. Whatever I told the steps to create a k nearest neighbor classifier, right? All those steps are same, except instead of knn object, we are going to use decision tree object. So all those four steps, like what are the four steps here? First step is create your means whatever the algorithm, for that algorithm create an object and then train your model and test your model and print the accuracy of your model. These attributes may vary based on your algorithm. These attributes will vary. That is called as parameter tuning. That parameter tuning we'll discuss separately. Currently, I will design a basic decision tree model, decision tree classifier. Maybe you can rename this variable also. So because decision tree, right? Decision tree model. Create an object for your decision tree classifier. And then you need to use this model to predict your train data. Means I need to train my model, right? In decision tree, there is a model, there is a function called as fit method, which is used to train your data. So my input data and input for that input data, whatever the outputs, I'm passing it to my model. So give the meaningful name, decision tree model, decision tree model dot predict. For this, I need to pass corresponding test values and which will give the predictions. These predictions I need to compare with actual outputs, then it will gives you score. Only what is the difference between KNN implementation and decision tree implementation is we are creating the corresponding object to predict to apply my corresponding decision tree algorithm. All the required mathematics, everything, whatever the decision tree construction like root node, intermediate node, leaf node, all those concepts are implemented in this package. In order to understand manual calculation, what is the theoretical concept behind decision tree, just go and watch my sessions on decision tree. There you can get a clarity how decision tree will be constructed. Here, if you use Python package, no need to worry about all those concepts are taken care in this package. And here I'm not mentioning any parameters. Those parameter tuning, I will take a separate session. How to do parameter tuning in decision tree, that we'll discuss in a separate session. Execute this and you can get the accuracy of your model. If you see Canon, it is 69 and decision tree we got 68. Still, it is very less accuracy. We need to improve this accuracy by applying different algorithms, or you need to fine tune your model, or you need to pre-process your data set so accurately so that it will give more accuracy. So there may be a lot of concepts in pre-processing your data set that we will discuss in separate sessions, like removing outliers or balancing your data set, that we will discuss in separate sessions. That's all for sklearn implementation on your diabetes dataset. Thank you.